use it. Okay, so very important section. That was 2.2.5 that we did. The chain rule formula. Okay, it was a composition of two functions. So let's just remind you, because there is one more problem that we have to discuss, and that's the tangent line problem that Noel was talking about. This is a kind of more general problem. Okay, so just remind you what we did because we have to do one more problem on this one. So that is the review of section 2.5. Okay, the review was, the formula was the formula of the chain rule. Okay, so that's a chain rule formula. And the chain rule formula is simply, if you have, is kind of power rule for the time being. Okay, we have a function, we call it u. So we have u to the n, a parenthesis raised to the n. Now, if you want to differentiate it, it's the composition of two functions, power function, u function. So we do the power first. You know that the power for the derivative would be n u to the n minus 1. That is the action of the power for differentiation. But since this is not x, this is u, you have to multiply u prime. Okay, so that's a chain rule formula that you're going to have. So if you have anything other than the x, okay, a parenthesis raised to something, so this is how we're going to differentiate it. So for example, we have kind of two types or four types. I'll just give you a couple of them to remind you. If you want to find the derivative of each function, okay, find the derivative of each function. Okay. So the type 1 is just a power function, something like f of x equal to the 2x cubed plus 5x everything to the 10. You see, as soon as you see a parenthesis raised to something, you just think about it. This is what you are going to call a u. Okay, so you think about it that, oh, I have u to the n. And you just copy this formula. Derivative of u to the n, power first, you see power down, 10, u to the 9, then the u prime. That's your formula. So we can copy the formula here. Okay, so if you copy that formula, your solution is going to be what? It's going to be f prime, power first. It's something to the 10, 10, 9. You see 10, 9, whatever you have, you repeat it again, and this would be to the 9. Now you have to pay for it. U prime, derivative of the inside. Derivative of the inside would be what? 3 times 2 would be 6, 6x squared plus y. And then you're done. Okay, so this is how you operate with the chain rule formula. Any question? So action of differentiation is just the power 10, 10, 9, 10u to the 9. But since this is u, it's not x. If it was x, derivative of x is 1, we are done. Okay, but you have to multiply derivative of the inside function. We say outside, inside. Outside is something to the 10, 10, 9. Inside, u prime. Okay, so that was a type 1. A type 2 is going to be a radical function. Okay, something like, let's have something like the 5th root of the x squared plus 2x. You see, you know that we don't like the radical in calculus. So what we're going to do is we change the radical first. So we have to rewrite it. So we rewrite it as what? G prime of, rewrite it, gx equal to, it's going to be x squared plus 2x, everything to a 5th. So now you have a parenthesis raised to something. So that's a chain rule case. So you can review it for yourself. So if you call this one u, so what you have to do is you have to find the derivative of u to a 5th. So derivative of u to the 5th, the chain rule. You see the power first, power down. So it's going to be a 5th. Okay, u to the 1/5 minus 1 is like 1 minus 5. 1 minus 5 would be negative 4. So that gives negative 4/5. Times it by the u prime. That's your formula. Okay, now we can copy that formula and bring the solution here. So what's going to be g prime of x equal to power first is going to be a fifth. Okay, a fifth x squared plus 2x to the negative 4/5. But you have to pay for it, u prime. U prime derivative of the inside, which is going to be 2x plus, okay, 2x plus 2, and you're done. See, very nice formula. Any question? So that's a case 2. The case 3 is going to be if you have a product of the function and the chain rule, okay? So I'll give you another one. There are 4 types. So if you have something like h of x equal to, you see h of x is equal to the, let's say 5x to the third, 5x to the third, and we have x to the fifth plus 2x minus 1. But this is to the 6. You see, this is a product of 2 functions. The first function is 5x cubed. The second function is this princess. So we have to apply the product rule. Remember the product rule? So the formula for this one is going to be the product rule. This is going to be f, the first, and this is going to be the second. So remind yourself that what formula are you going to use? You are going to formula, of the derivative of a product of 2 functions. So it's going to be derivative of the first one, which is f prime, times the second one, plus derivative of the second one times the first one, s prime of f. Okay, so you note that this is the main formula that we are going to apply. So apply this formula. Okay, derivative of the first times second is easy because what's the derivative of 5x to the third? Is going to be 3 times 5, 15 x squared. Okay, so this is going to be officially the solution of your problem. So we start with the h prime of x. You see h prime of x is going to be equal to derivative of the first one, 3 times 5 would be 15 x squared. Okay, that's derivative of the first one. Times it by the second one. Okay, times it by the second one, and this is it, times by x to the fifth plus 2x minus 1, everything to the 6. So that's the derivative of the first times second. Any question? Now the point is the second first. You see the derivative of a second first, the second is what? The second is u to the 6. So for the second one, you have to use the chain rule. Okay, you may remind yourself, oh, what I do? What I should do here is I have u to the 6. So you remind yourself that derivative of u to the 6 would be what? Would be 6 u to the fifth times u prime. See? That's when you bring the chain rule. And so we operate with the second one. So the second one would be that 6, 5, you see, plus 6, 5, just changing the power, x squared plus 2x minus 1 to the fifth times u prime. U prime derivative of the inside. Derivative of the inside would be, okay, sorry, that's a 5. Okay, x to the fifth, 2x minus 1. That's going to be 6/5. Now derivative of the inside would be 5x to the fourth. Okay, 5x to the fourth plus 2. Okay, so that's a 6u to the fifth times u prime, which is derivative of the second one. You times it by the first one. Times it by the first one. 5x cubed. Okay, any question? So derivative of the first times second is ordinary differentiation, because that simply give you 15x squared times the second one. But derivative of the second times first, you have more work to do, because this is of the form of the u to the 6. Okay, form of the u to the 6, so we differentiate u to the 6, that's it. You bring the 6 down, 6 u to the fifth times u prime. So we operate exactly the same thing here times the first one. You're not done because you have 2 monomials here, remember? Those single term, you have to put them together. So that would be 6 times 5, which is going to be 30. So you have to rewrite this one. You're not done. So the final answer now is going to be h prime of x is going to be equal to Okay, that's a 15x squared times x to the fifth plus 2x minus 1, everything to the 6. Now you multiply these two together, 5 times 6 times 5 would be 30. We get the 30, okay, 30x cubed. Just repeat the rest, x to the fifth, 2x minus 1 to the fifth, times u prime, which is 5x to the fourth plus 2. Say that would be a product and the chain rule. So these are all the possibilities. Then when you do the chain rule type, and we get 2 questions of this one, as I told you the other night. Okay, on the next quiz, next test, and on the final. On the final, we give you differentiation only from the chain rule type. Okay, any question? So just this was just to refresh your memory. So as an application, like the question that we were just talking about, the application of the derivative is what is problem of a tangent line. So a problem of a tangent line would be given to you, but they are going to construct it so that you have to use for the derivative, you have to use the chain rule. Okay, so that would be the second question that you are going to have for this section. Okay, any question? So I'm going to give you one tangent line problem to see how we're going to operate with the chain rule. Then we are done with this section. Okay, so this is new example. Again, this is a tangent line. Anytime you talk about something in derivative, quickly you are going to provide this problem. Equation of a tangent line. So what's going to be the function that you have to use the chain rule? That's it. You get 1 on the on the quiz. Find the equation. Okay, find the equation of the tangent line. Of the tangent line. Tangent line to what? To the graph. To the graph of this function. F of x equal to, okay, f of x equal to let's have something like cube root of the 7x plus 1. Okay, find the equation of a tangent line to the graph of f of x equal to the cube root of 7x plus 1 at a point. Okay, at the point with the x coordinate of 1. See, that's a tangent line problem. You did have it before, but we give you, we gave you a polynomial. And now we give you this function. Okay. Now, you know that in order to write the equation of a tangent line, there are going to be 2 steps. Step 1, we need a point. So x coordinate of the point is given to x equal to 1. So you substitute in the function that give you the y value. Then we have a point, x and y coordinates. Okay, that's the first part. The second part, we need the slope. This is the derivative calculus. So derivative of a function is going to be the slope as we talk about it. So what you have to do, you have to find the derivative of this function. Then you substitute x equal to 1. But this is a radical function. You know that the radical function, you rewrite it, then you have to apply the chain rule. So this is where the chain rule is coming. This is where you want to find when you want to find the derivative of the function, then you have to apply the chain. Okay, that's why this is a popular problem. Okay, so we go for it. Solution, 2 steps. Step 1, you ask yourself, where is the point? Okay, where is the point? And now we have the x. X is equal to 1. Now we're going to substitute x equal to 1 into the function, okay? So we're going to substitute into the function, so that gives us f of 1 is equal to, it's going to be cube root of, it's going to be 7 times x, is 7 times 1. So which is going to be 7. Okay, so we get 7 plus 1. 7 plus 1 would be 8. So we have a cube root of 8. And you know that the cube root of 8 is equal to 2. So we have a point. So the coordinate of the point is going to be 1, comma 2. In your book, uh, the points are given. Okay, they give you the point with the x and the y coordinate. So for those problems, the first step is already done. But we would like you to find it yourself. So that's why we give you x only, then you substitute to get the y. Okay, any question? That's a step 1. Step 2, we need the slope. So what's going to be the slope of the line? Like the problem that we've been talking about. Okay, the slope, this is calculus. The slope, m is equal to what? Is going to be derivative of the function. What is the derivative of the function? Is, you have to find the f prime. Then in the f prime, you substitute for x equal to 1 to get the, to get the slope. Okay, so we have to find the derivative of the function. But the function is a radical function, so we have to rewrite it, okay? So we have to rewrite the function. This is it, f of x equal to, we rewrite it, you know that's going to be 7x. It's going to be 7x plus 1, everything to the what? Everything to the 1/3. Okay, so m is, that's it, that's your function. So you have to differentiate it. So you remind yourself that it's a type of the chain rule type, okay? You may copy the formula for yourself, say, oh, so I have to use this formula, u to the 1/3. And you know that you bring the 1/3 down, the power down first. It's going to be 1/3 u to the 1 down. 1/3 minus 1. It's going to be 1 minus 3, which is a negative 2. So that gives a negative 2/3, okay? But you have to times it by u prime. Any question? So that's a different, difference between this problem and the previous one that we've been talking about. For this problem, you have to find the derivative and you have to use the chain rule. Okay, so we copy this formula to get our derivative done. So it's going to be f prime of x is equal to, that's it, power down, which is going to be 1/3. Okay, that's going to be 1/3 u, just power down, 1/3, 7x plus 1 to the negative 2/3. Okay, negative 2/3. Now multiply by u prime. U prime derivative of the inside, derivative of the 7x plus 1, you know that derivative of 7 is just 7x is 7, derivative of 1 is 0. Okay, so that's a 1/3 u to the negative 2/3 and u prime. Now we multiply these two numbers together. So your f prime of x is going to be equal to 7/3. Okay, 7/3, and you get a 7x plus 1 to the negative 2/3. Okay. Now to get the m, you have to plug in x equal to 1. So that would be f prime of 1. F prime of 1 would be 7/3. Okay, 7/3. Again, this is going to be 7 plus 1. 7 plus 1 to the negative 2/3. Okay, you got to be careful to simplify this one. So this is going to be 7/3. Inside 7 and 1 would be 8. So that gives 8 to the negative 2/3. Okay, the way we are going to find the 8 to the negative 2/3 is going to be interesting. So I show you how we are going to find it. You see, you can use your calculator if you like, but this is going to be 8 to the, you see this 8 to the negative 2/3. So what we do the 8 to the 1/3 first. You see, this is the way you can rewrite it. It's going to be 8 to the 1/3, then to the negative 2. This is what you do in algebra. Okay, 8 to the 1/3 is cube root of 8. You see, this is going to be, this is inside the parentheses, it's going to be cube root of 8. Okay, then to the negative 2. Cube root of 8 would be 2. 2 times 2 is 4. 4 times 2 is 8. So that gives you 2. 2 to the negative 2. Now 2 to the negative 2. 2 squared is going to be 4. You see, you can think about it as you do the 2 squared first, then you raise it to the negative 1. So 2 squared would be 4. So 4 to the negative 1 and 4 to the negative 1, you're going to flip it and write it down as a quarter. So this is the way you do the algebra. And it's happened for these type of problems because we give you a radical one, okay? Because the other ones, we have nothing to worry about. Okay, so a little of algebra, just use your calculator. It can be done, okay? So it's a 7/3 a to the negative 2/3. So we do a to the 1/3 first because it's easy, because a to the 1/3 is 2. Okay, they give you some number that you'll be able to take care of it. So we do the a to the 1/3 first, going to be 2, 2 to the negative 2. Positive first, 2 squared would be a positive 4. But since it's a negative, you have to flip it and write it down as a quarter. So we come back, and this is going to be a quarter. Okay, so f prime of 1 is equal to the 7/3. Okay, it's going to be 7/3 times it by a quarter. So now the result is going to be 7/12. So f prime of 1 is equal to the 7/12, and that gives you the m. You know, the slope of the tangent of a tangent line. Okay, any question? That is going to be you have to use this one. You cannot give us an answer in the decimal form. Some calculator will do this operation. It must be exact. You cannot say that m equal to the 0.0 something. No, because if they give you a nice number, you have to follow the algebra to get this number done. Okay, use calculator for application problems. Okay, if it's going to be something about dollars, miles, and this is the way we do it. Okay, so it's going to be a couple of cases. It's going to be cube root, fifth root. So it's going to be 8, 4, 32, 16. So the number is going to be nice. And it's good to know to get through this one, to get the m equal to the 7/12. And now we are ready. We have a point and we have the slope. So we can write down the equation of the, we can have the equation of, write the equation of a tangent line, okay? So there you are. We have the point 1 and 2. You may call it x1 and the y1. And we have the m, 7/12. And you have the formula. Remember the formula? Y minus y1 equal to the m times x minus x1. Now we substitute y minus y1 would be y minus 2. M is 7/12 times x minus x1, which is x minus 1. You have to simplify, so it's going to be y minus 2. Distribute the 7/12, 7/12x minus 7/12. Okay, add the 2. So y would be 7/12 of x minus 7/12 plus 2. You have to find the common denominator here to simplify it. So I'm going to rewrite it as this is 7/12x. This is 7/12. I want the denominator to be 12, so I change the 2 into the 24 over 12. Okay, now we can negative 7 out of 24. So y is equal to 7/12x. And if you subtract, so that gives what? That gives 17 over 12. So that would be the final answer. The problem of a tangent line when you're dealing with the, dealing with the chain rule formula. Any question? So it takes a little bit time. It's going to be longer than the usual one because of the derivative that we have to go through it, but it's not bad. Okay, so you have to be careful when you want to find the slope. In this case, it's going to be the slope of a tangent line. Your function is, you have to differentiate, but your function is going to be the chain rule type. So you get, you get the radical, very mild radical, you switch it. In this case, happen to be u to the 1/3, and then we differentiate it and just we go through it. Say we get one in your practice one. You have a couple of them in your book. Okay, any question? So that's a question on the chain rules that we talk about it. So there are 4 functions to differentiate and kind of 1 application so far. Okay, so we are done with this section 2. Section 2.5. That this is, you have exactly 1 in your book. That's the, you see, look at this one. This is the example of your book. Find the equation of a tangent line. You have a cube root of x squared plus 2 square at x equal to 2. So if you just switch it, it's going to be similar one that I did. So you have a couple of examples of this one on your assignment. So just check them. Then if you have any difficulty, we do it again for you. So you have you see these are going to be the one, this part, and these are the type that we are going to be interested in. You see 1, 2, 3. And so in your book, they ask you to graph it. You don't have to graph it on the test. They ask you to use a graphing calculator or something to graph. No, we just want to just get the equation of the tangent line, and they are all. These types are much easier when there is only power. But we are interested in the radical form. Okay, so make sure you do a couple of them, and you will see it in your practice one. Okay, that's it. Any question? So that's a 2.5. Now, a 2.6 is very easy section. Okay, quickly, I'll just give you an idea. We are going to use this section in future. For the time being, you are not going to do much about this. You see, so far what we have done, a function is given to you, find derivative of the function. And you know that derivative of the function is rate of change. Depends where you are. If it's going to be cost function, revenue function, these are going to be rate of the cost, rate of the revenue, etc. If you have a moving object, we talk about it, derivative would be the velocity. But sometimes you may be interested in some other quantities, okay, in science. So we are going to introduce so-called higher derivatives, if you like. Higher derivatives means, you see, if I give you a function like the one that we did here, you see this function, you just find the derivative of the function. So the function was f of x, you differentiate it, you get f prime. So that's a derivative function. So sometimes you may need to continue. You see, this is f prime. If you differentiate the f prime, you are going to get a new function. That function is going to be called the second derivative. You see, this is going to be the first derivative because you differentiated once. You can differentiate this one, go to the second, to the third, to the fourth, to the sixth, etc. In your discipline, you are going to go up to the second. But if you are going to be physics, chemistry, etc., you may go to the higher one. So in future, we need just the second derivatives. So that's why I just give you a couple of examples of the next sections, and we are not going to question you so far because we don't have much to talk about it. But in future, we need it. Why we need the second one? The second one is going to be interesting in everyday life. The first derivative would be rate of change or the velocity. The second derivative for the moving object would be acceleration. So if you are measuring physics, okay, you'll be very much interested in to see what's going to be the velocity of the moving object or what's going to be the acceleration. But in our case, when we get the application of problems, we are going to be interested in finding the maximum and the minimum. We're going to have a test. We call it the second derivative test. This is where you need that second derivative. Otherwise, you are not going to use it, okay? So I just briefly give you the definition, and then we leave it for future that we are going to use it. We are not going to do anything for the time being, okay? So that's the idea of 2.6. 2.6, higher order derivative, we call it, okay? 2.6. Okay, 2.6, what's going to be higher order derivative. Derivatives Just go with the second. This is all we need. Okay, so if you give me a function, okay, if a function y equal to the f of x, if this function is going to be differentiable, okay, this means you can find the derivative. Okay, then you're going to have what? Y prime, which is the same as f prime of x, is going to be, okay, this is going to be the first derivative. Okay, this is going to be called, okay, derivative or just the first derivative? The first derivative of the function, of the, okay, of the given function. Okay, so that's going to be the first derivative, and that is what we were, we were working on it. So that was going to be the case. Now, if this new function is differentiable, okay, if the derivative function, we introduced this one before, derivative function f prime, or the first derivative by itself is going to be differentiable. Means you can start it over and differentiate it. So if the derivative function f prime is also differentiable, if it's going to be differentiable, then we differentiate it. Then you're going to write, you see that was y prime, you say y double prime equal to f double prime of x. Now this is going to be called the second derivative of the function f. Okay, it's going to be called the second derivative. Okay, this is going to be the second derivative of the given function. Given function f. Okay, so f prime is the first derivative. If you differentiate it again, that gives you the second derivative. Similarly, we can define, okay, similarly, one can define higher, if you like, order derivatives. Higher order derivatives, this means, so you are going to have the f prime. If you differentiate it, that gives you f double prime. If you differentiate it again, so that give you, okay, the third one. And then you continue. The fourth one, this is the way we denote it. We say f to the fourth, but we put the parentheses here, f to the fifth. Okay, etc. Fn. Okay, this is going to be where, if you like, and you say Fn with this parenthesis is going to be okay, this is going to be the nth derivative. Okay, or the derivative of order n, if you like, is going to be the nth derivative. Okay, of the given function. Given function f. Okay, so it depends on the application that you're going to have. You may go on and get these, various type of the derivative. Okay, so this is going to be the case. Any question? The second one is interesting. Okay, you are going to see the role of the second later on and the various applications that we have. So I'll just give you one example and I'll just go with the second one. We don't need anything else from this section for the time being. Okay, so we would like to find the second derivative. The second derivative of the function. Okay, one example would be enough because we are not going to do much. Sometimes, you can give me a very complicated function. It takes quite a while to do it, but we are not going to use it. So we are not going to spend time on it. We just remind you, and then when we get to the action of the application, you are ready for it. You see, suppose this is the most that we're going to have. You may be given this one in future. Okay, 2x cubed plus 5x squared minus 3x plus 10. This is going to be a function that would be given to you. You want to find the first and the second derivative. So we are ready to to do it. I'll just give you 2 because I need another one. Okay, this is going to be the first one. You just differentiate it. You differentiated the first and the second one. Okay, so this is going to be the solution. Ordinary differentiation. No chain rule is going to be used for these type of problems. Okay, so we differentiated once. F prime of x is going to be equal to action of differentiation. 3 times 2, 6 is going to be 6x squared. Okay, 2 times 5, 10 is going to be plus 10x. And 1 minus 3 is going to be just a negative 3. You say that's going to be the first derivative. But you've been asked to find the second derivative. So we have to go on, get the second. Okay, so it's going to be f double prime of x. Do the same thing. Okay, do the same thing. So it's going to be 2 times 6, 12. It's going to be 12x. Okay, and this is going to be 1 times 10, 10. So this is going to be the second derivative of the function. In future, you are going to have 2 problems related to this one that we're going to discuss, and probably you will see it in your maybe test 3, and of course on the final. But for the time being, this is all we are going to have. Okay, it's used. The second derivative is used in. Okay, we have something we call it the inflection point. We talk about it. There is a quantity we call it curvature. The curvature is when you drive. You see, when you drive, you get to the curve on the roads. Your car will do it for you. Okay, but the measurements that how going to drive on the curves are coming from the second derivative. There is a measurements that we call it curvature. And that's the measurement that they use when we want to design the freeways, okay, roller coasters, even when they want to use it in case of the, okay, eye surgery or building those eye lenses, okay? So it's quite a lot to talk about the second derivative. But for the time being, we don't have any tools if you like to go for it, okay? So just be aware when we talk about second derivative in future, you know what we are going to do. Okay, any question? There is one typical example that we're going to use it quite a lot, so I give you a hint for that one. This function is coming in a couple of examples or application problems, and the function is this one. It's not something difficult. I just want to give you something to think about. Okay, it's going to be g of x, and the function is going to be this one. It's going to be x squared plus, okay, it's going to be x squared over 5 over x and minus 100. Okay, that's going to be the one. Then you want to find the second derivative of this function. You see, this is going to be something like 5 over x squared to the 5th to the 6th. My recommendation is you just move this one up first. You change it to the 5 to the x to the negative 1. Some people, they use quotient rule. You don't need a quotient rule for this type of problems, okay? So you just, when you move it up, it's going to be easier for you to differentiate it, okay? So that's the only point about this problem. So I'm going to rewrite it. It's going to be g of x equal to I have the x squared. So I move the x up, so make it to the 5x to the -1 minus, okay, minus 100. Now you differentiate it. To find the first derivative, which is going to be g prime of x, okay, g prime of x equal to x squared would be 2x. Okay, now this one, you got to be careful. Exponent times coefficient, that give a -5, 1 down, that give x to the -2. Okay, and derivative of 100 is going to be equal to 0. Any question? We just differentiating just using the power rule. Okay, exponent times coefficient, -5, x to the 1 down, it's going to be -2. So that's going to be your g prime. But you will ask the second derivative, so we can find the second derivative. Okay, so that will be g double prime.
Can you say it again how you got the -2 exponent?
You see, you subtract 1 from the top. You see, -1 times 5 would be -5, x to the what? 1 down. -1 minus 1, which is a -2.
Oh,
Because it's a negative number, it's going to be -1 minus 1, -2. Okay. Now we want second derivative. So we have to continue. G double prime. G double prime. Again, 1 times 2 would be 2, 1 down. We get 2 only. Then we have to repeat this one. -2 times -5 would be a +10. +10 x to the, again, 1 down. It's a -2 minus 1, which is a -3. You see, that will help you to be able to write it down nicely. It's a very popular problem. This is 5x. There's going to be a couple of terms here, 5 over x, 7 over x squared, when we get to that application problems. Otherwise, we don't need anything complicated. You have some in your book, but there is no application for the time being. Okay, so that's the idea of the higher derivatives, if you like, higher order derivatives. The first, the second, as I told you, for the time being, that's the most we can have. You are not going to be questioned on this one. But in future, we get back to it when we get to the application problems. Okay, any question? So that is the idea of the 2.6. Okay, the higher derivative, if you like. That will take us to the one more section. We have 2 more sections in this chapter to finish it. Okay, so we go to the 2.7. It's not a difficult section. The purpose is going to be sometimes some people they skip this one, but there are a couple of places in business that you are going to use these ideas. Okay, so we're going to talk about it. Not bad. So what is going to be this section about? You see, look at this function that I give you. You see all these function, you have f of x equal to the function. The equation of the function is given to you. We say directly is given to you. You say g of x equal to. Or sometimes, we replace this f of x by y, and we say y equal to. You see, if the function is given to you, this is a standard format of the equation of a function. So if the equation of the function is y equal to the f of x, we differentiate. We differentiate derivative of y would be y prime. We just call it y prime. Okay, and on the other side, we use the power rule to get the derivative of the function. This is one format. But when you are in application problems, sometimes it's not the case. You see, it's not the case that the equation would be given to you as directly, we call it y equal to. They may give you this equation, but the equation is going to be a mix of the x and the y together. Okay, so it's like, x squared plus y squared equal to the 7. So if this is going to be the case, you have to do something to modify your formula for the differentiations. So if the equation function would be given in this format, we say the function, the equation of the function is given The expression is explicitly. Explicitly means directly. So directly y is given to you. You differentiate it. But if x and the y are going to be together, okay, mixed together, in that case, we say this equation is implicitly defined. Implicitly means there is a y. There is a y. Go and find it if you can. But sometimes it's not possible to solve. So we want to know how we're going to take care of the derivative of those functions. Okay. So this type of differentiation, they refer to it as a implicit differentiation. Okay. And that's the idea of the next section, 2.7. Okay. So we propose the problem. We try to make sure we understand it. And then there is no new formula really. We just use the power rule to find the derivative of that function too. Okay, so that's going to be the idea of the next section. This section can be getting complicated, but if you know, if you have some trigonometric function, the sine, cosine, this type of function, and you don't have it, the most you have in business or in social science, if you like, you have the natural log function, and you can take care of it. Okay, and you need it for those applications. So that's the idea of 2.7. Let's take the 2.7. That's almost the last type of differentiation that you have in this book. Okay, then you are not going to have a new one, and then we go to the applications. So what's the idea of 2.7? The expression is implicit. Okay, it is implicit. Okay, implicit differentiation. Implicit differentiation. That's the idea of this section. So we're going to define what is implicit function means and what is eventually is going to be derivative of the function. Okay, so I just remind you this definition from algebra, that format of the functions that we can have. So if a function, okay, if a function f is given, it's given directly, okay, it's given by the equation, okay, given by the equation, like y equal to the f of x. So it's already solved for phi, okay? If it's going to be the case, then we are going to tell you that, oh, then f is set to be, okay? F is set to be and explicitly defined, okay? Explicitly defined function. Okay, explicitly defined means y is directly given to you. That is going to be explicitly defined function. In this case, if you want to differentiate y prime equal to the f prime of x, and then you do that. Okay, so in this case, okay, the derivative of the function, the derivative of the function, okay, is going to be is y prime equal to the f prime of x. You're just using the power rule and you differentiate it. Okay, that's the type that we've been doing so far. Okay, the function was given to you nicely, y equal to, you differentiate it, and you get the derivative. Okay, let's get one example. For example, okay, if we're given something like y equal to, okay, y equal to the x cube minus 4x squared plus 2x minus 7, You see, this is a explicitly defined function. We find the y prime. So then what's going to be y prime? Derivative. Derivative of y would be y prime. And we're just using the bubble rule to get our derivative, okay? So exponent times coefficient, so that gives us a 3x squared. 3x squared minus what? Minus 8x plus 2. That would be the derivative of the function. Okay, any question? So that's what we know so far. Okay, that's what we know so far because y was given to us. Now what's the problem? The problem is sometimes y is not going to be directly given to you. Okay, and it would be difficult to find it. So what is the problem? So the problem is if, okay, if a function f this time is given again, is given by an equation in terms of the x and y together. Okay, in terms of x and y together, such that you have something like this, you see? You have a function, this is going to be x comma y equal to the 0. So this means x and the y are mixed together. Look at this one. In this case, y is given to you directly, so it's not mixed together. So it's solved for y. But this one over here, if you like, you have to solve it for y. But the difficulty is, it's not going to be easy to solve. Okay, so if a function f is given to you, that's going to be, okay, inside an equation, then we say that, oh, then, okay, if this is going to be the case, then the function f, eventually y equal to the f of x, okay, is said to be and implicitly defined, not explicitly. Implicitly defined function. You see? Implicitly defined function. Okay, so implicitly y is somewhere. Go and find it. It's not explicitly given to you. Okay, so for example, if you have something like this one, look at this one. If you have x cubed plus x y squared, okay, plus y cubed, for example, you make it as complicated as you like, equal to 2x minus 1. Look at this one. So we have an equation, x and the y are together, okay? So there is a function y. That function would satisfy this equation, but it's not easy for us to find the y. It's impossible, you see, to solve for y. In algebra, sometimes, those examples are easy. So in this case, we say, oh, this y is given to us, not explicitly, implicitly. It's inside. Okay, so if this is going to be the case, then this y, the function, y, it's going to be of the form of the f of x is going to be what is given to us is implicitly defined by the given equation, by the given okay, given equation. So that's it. That's a difficulty, and this is going to be the problem that we have to investigate. Okay. Any question? So make sure you know the difference between these two ideas that we are going to have. The question is going to be, you see the first one, because this is calculus, we are interested in y prime, derivative of the function. You see, for the first one, it's done, because y is already given to, derivative of y would be y prime, and you are done. But for this one over here, you see, when you want to differentiate this type of function, we start differentiating. All the rules that we talked about it before are going to be satisfied. So when we get to the x, the power of the x, you know that, for example, derivative of x cubed would be 3x squared. But when we get to the y cubed, look at the y cubed. What is y cubed? You see, this y is a function of x. So this y is like u that we did before, because the y is something that you don't know it. So when we get to the derivative of the y to the third, it's like u to the third. We have to use the chain rule. Remember, when we have a chain rule, it's going to be power down. It's going to be 3y squared, but you have to pay for it. Remember, the pay for it was u prime. In this case, it's going to be y prime. So this is where you are going to bring the y prime, and eventually you are going to solve the equation for y prime, and then you're done. So if the equation is given to you implicitly, you differentiate it. Okay, you differentiate it. When we get to the x, you just use the ordinary power rule. Derivative of x to the n is nx to the n minus 1. But when we get to the power of the y, you have to apply the chain rule. You see, that's going to be the difference between these two. So I give the instruction, that I give a break, and then we come back and we work on it and get this done. That's it. That would be the end of this type of ideas. Okay, so let's explain the problem. This is going to be the case. Now, if the function is given to you, okay, if a function, okay, a function y equal to the f of x, you can call it u if you like, it's the same thing, is implicitly defined. Okay, implicitly defined by the equation, by this equation that we talk about it, equation f of x and y means they are mixed together, equal to the 0. So then, in order, okay, in order to find y prime, in your book they call it, they want to give you something, you seems to be different, but you can use it if you like. They call it dy dx. It's the same thing, but I'm not going to use this notation, but you can use it if you like. It's the same after y prime. Some people, they like it. They think that it's something different to memorize it, but it's the same thing. We are going to talk about this one later. Okay, so in order to find the y prime or dy dx, what do? You differentiate both sides of the equation. Okay, differentiate. We are going to differentiate both sides of the equation. Okay, both sides of the equation. Okay, by using the power rule formula. By using the following power rule, if you like, using the following power rules. Now, what's going to be the power rules? When we get to the x, you see, derivative of x to the n is going to be nx to the n minus 1. Derivative of x to the fifth is 5x to the fourth. Derivative of x cubed is 3x squared. But when we get to the y, you think about it as a chain rule. You see, if you get a y to the n. Now it's a composition of two functions, the y function and the n function. Okay, the power function. The power first, n, y to the n minus 1. But you have to multiply by y prime. This is where we get the y prime. Remember, it's a chain rule. Because the y is just a function of x. Okay, so when we get to the x's, we just use the usual nx to the n minus 1. When we get to the power of the y, we apply the power rule, but you multiply by y prime. There is a y prime here, and then you solve for y prime. And then solve for y prime. This procedure is going to be called implicit differentiation. In action, it's going to be very easy to apply. And the people usually, they are very happy about this one. And we don't have any difficulty because you have only two cases and you can apply it and get it. Okay, I'll give you a break. We come back and we work on this one. Okay.
Professor, sorry, I have a
Yes.
question. So
Yes.
for the x cubed plus xy squared, for that one, would the answer just be implicitly?
No, you see, this is y is given to you. That's explicit. You differentiate.
Mhm.
That's a normal differentiation.
Yes.
But this one is not the case. You see this one? When we get to
So,
the x cubed, derivative would be 3x squared.
yeah.
But when you get to the y cubed, derivative of y cubed would be 3y squared y prime. You see, I write a couple
Yeah.
of them over here so they can see it. You see, if you
Mhm.
want to find the derivative of y squared, chain rule, 2y y prime.
Mhm.
If you want to find the derivative of y cubed, 3y squared y prime. You see, you have this y prime because the y is a function. You don't know it. You keep, you don't know it. You keep a place for it, for example. You see, y is something like, by itself, x squared minus 2x plus 1 to the second power, to the third power. So that's why we keep the y prime, y prime, y prime. But
Okay.
for the x, no. This is the derivative of x squared. You see, it's 2x. Derivative of x cubed, it's just 3x squared. So this is the y prime that you solve for y prime to get it. Okay, that's it. That's the difference between the first one. I give you an example, and you'll be fine.
Okay. Thank you.
Okay, 10 minutes, we come back and we try to finish this one. We need to work on this one and carry up application, and then there's nothing else in this section except this one. Okay, so see you in 10 minutes. Okay. So let's give you an example to see how we're going to operate with this type of problems, okay, using implicit differentiation. There are kind of two types of examples only in your case. Okay, so this is going to be a kind of type 1. The one in your book, they are much easier, but we have to look at a couple of them as well. So we give you the instruction, okay, apply the implicit differentiation, implicit. This procedure is called implicit differentiation. Applied implicit differentiation. Okay, implicit differentiation to find y prime. Y prime, or as is in your book, if you like the one in your book, or dy dx. Dy dx for each given function, okay? For each given, okay, for each given equation. Given the equation, okay? The type 1 is this one. It's going to be, you are going to have just a power of y. So something like x to the 5th, okay, plus y cubed, plus y cubed, and this is going to be equal to the 2x plus 3. So that's going to be the one. So we want to differentiate to find the y prime. Okay, start differentiating. When we get to the power of the x, it's just the usual power rule. But when we get to the power of the y, it's a chain rule. So you end up with the way you apply the power rule, but you multiply by y prime. Okay, so the solution is going to be derivative of x to the 5th is 5x to the 4th. Done. You see, that's one. Plus, we get to the y cube. The power rule first. You see, y cube would be 3y squared. But you have to multiply by y prime. That's it. Okay, because that's a chain rule. That's a chain rule because the y is a function. It's like u cubed. U cubed, you see the derivative of u cubed is going to be 3y squared, 3u squared, u prime. So we go to the other side, just the usual one, derivative of 2x is 2, derivative of 3 is 0. Okay, any question? Now we have to solve for y prime. Solve for y prime. To solve for y prime, you have to isolate the term containing the y prime. So you keep this one, it's going to be 3y squared y prime. Then you have to subtract the 5x to the 4th. It's going to be 2 minus 5x to the 4th. Okay, we isolate the term containing the y prime. Now we want to find the y prime. This is 3y squared y prime. So we are going to divide both sides, okay, by the coefficient of the y prime. You divide by 3y squared. So it's going to be 3y squared y prime. And this is 3y squared. And this is going to be equal to the 2 minus 5x to the 4th divided by 3y squared. Now the 3y squared and the y squared would cancel out. I can do it right away. I just explain it. So the result is y prime equal to 2 minus 5x to the 4th over 3y squared. That's it. This is the derivative of the function. Any question? So it's a nice, nice procedure. So the difference is going to be the way you look into the derivative of this function. This is x to the 5th, is a 5x to the 4th. But you see this y is like parenthesis. It's a parenthesis to the 3rd. So there is something inside the parenthesis. So parenthesis to the 3rd would be 3 parentheses squared. But remember, you have to multiply the derivative of the inside, which is y prime. So anytime you apply the derivative to the y, you apply the quotient rule, apply the power rule, times it by y prime. But you have to differentiate both sides of the equation. Derivative of the 2x is 2, derivative of is 3 is 0. Then you have to solve for y prime. So for y prime, we isolate it, we keep it on one side. We subtract the 5x to the fourth. Then you divide by 3y squared. You can divide it right away, but I just explain it. You divide and that gives you the y prime. You see, when you have the y prime, you see that's interesting because we don't have the y, but we have the y prime. And in calculus, the y prime, in business, okay, in application, the y prime is the one that is going to be used because you need the rate of change. So that's why this is going to be interesting. Any question? I use this notation. If you want, I can show you the notation of your book, but I don't recommend it. You see, this is the notation of your book. In your book, they differentiate x to the fifth. The same thing that give you 5x to the fourth. But when they got to the y cube, they write 3y squared. They times it by dy dx instead of the y prime. Okay. And then the other side is going to be just derivative of a 2x is 2. Then they solve for, it's the same thing. They solve for dy dx. So this is going to be 3y squared dy dx equal to 2 minus 5x to the fourth. Then they divide by 3y squared. So that gives you dy dx, which is going to be equal to the 2 minus 5x to the fourth over 3y squared. This is the notation of your book. If you like this notation, you want to use it, I don't mind. But I use the y prime. That's going to be the difference. Okay, so that's the idea of it's just a chain rule that we are going to use to get these numbers. Okay, this is going to be the one. That is going to be the case. You're just solving for y prime. You see, that's it. It's like an equation. How do you solve an equation? And you write, equation 5x equal to 10. X would be 10 over 5. So you always divide by the coefficient of the unknown. This is the coefficient of the unknown. You need y prime. So everything else you have to divide. It's like solving ordinary equation. Okay, the coefficient of y prime is going to be down the denominator to get these numbers done. Okay, any question? That's a type 1 when we get a power of the y. Some people on the test, they are very happy. They have a shortcut. And they give me a formula. Probably they got it. If you search these type of problems everywhere, they give you something that it's not going to be using the implicit differentiation. We don't, of course, accept it. And that's something that we call it a function of two variables, and we use it in calculus 3. So some people, they memorize that one without knowing what's the concept. If you do it, we give you 0 because you have to explain it to us, okay? So implicit differentiation, that's why we say apply implicit differentiation, okay? To be able to find it. We need a chain rule to get this problem done. Okay, any question? That's a type 1. Let's see what's going to be the type 2. You see the type 1? There is only one power of y. In type 2, there may be a product of x and the y together as well, okay? So that's only the other possibility. Let's get the type 2. Nothing else. What's the type 2? We have the x cube here. Okay, this is x cube plus, okay, plus how about x squared, okay, y squared. And you want to make it more interesting, and you have something like y to the fifth plus 7x. That's a kind of most general one that you can have. Not complicated, but the most involved. Okay, we want to differentiate it, okay, to find the y prime. So let's see what's going to be the problem. Are you ready? Solution. Let me tell you what will happen, then we write it down. You see, when you want to differentiate the derivative of x cubed is clear, it's 3x squared. Be done. When we get to this one, we see it's x squared times it by y squared. So this is the product of two functions. So when we get to this part, you have to apply the product rule. Remember the product rule? Derivative of the first times second, second first. It's like the chain rule and the multiplication that we talk about it. So derivative of the first one will be 2x times second, 2xy prime, y squared. But derivative of the second times first, derivative of y squared, you have to apply the chain rule. So derivative of y squared would be 2y y prime. So you have to apply the product rule for this one. This is clear. Y to the fifth is just 5, y to the fourth, y prime. So the difference between the other one is this term over here, okay? So don't miss it, the product rule for this one. So what's going to be the result? If of x cubed would be 3x squared. Now we have to apply the product rule plus. The product will receive first, second. If of the first one, if of x squared is 2x. First times second, 2xy squared. Plus. If of the second one is y squared. You see y squared is like u squared. It's going to be 2y y prime. So the derivative of the second one would be 2y y prime multiplied by the first x squared. Okay, so we apply the product rule to get this one. The derivative of the first one is 2x times y squared, done. Plus the derivative of the second times the first one, y squared, derivative of y squared is 2y y prime times the first one, which is x squared. We go to the other side, the derivative of y to the fifth, it's a chain rule. You see, it's like u to the fifth. It's 5, y to the fourth, pay for it, y prime. So it's going to be 5, y to the fourth, y prime. And the derivative of a 7x is 7. That's the kind of most complicated problem of the implicit differentiation that you can have. Any question? Now the algebra part is a little bit more. So what you want to do, you want to solve for y prime. So you have to isolate the y prime. You see the y prime? You have one term here, and you have one term here. So you have to collect them everything to the left, okay? So this is going to be 2y. You can write this in alphabetic order if you like. You can switch them if you like. It's going to be 2x squared y prime. That's better. You don't have to, but that's nice. Now we bring this one here. It's going to be negative or minus 5 y to the fourth y prime. Okay, so this is going to be all the y primes that we have. Everything else, you put it on the other side. You get the 7 here. You get the 7 here. So you have this part. We have to move this one to the other side. We have a 3x squared. It's going to be minus 3x squared. And then you subtract this one. It's going to be minus 2x y squared. Okay, all the y primes in one side, all the y primes in one side, everything goes on the other side. Now, we need to have only a single y prime. We have two here. You cannot combine them together. So what we do, we factor out the y prime. You see, factor out, because you need that coefficient, remember, to divide. You factor out the y prime, so that gives you 2x squared y minus 5y to the fourth. Everything times what? Times y prime. So you pull out the y prime if you like. And then you have the 7 minus 3x squared minus 2x y squared. Now this is the coefficient of the y prime. You divide by this coefficient. So what's going to be y prime? Y prime would be equal to, you see, this is what you have here, 7 minus 3x squared minus 2xy squared. Now you divide by what? Divide by 2x squared y minus 5y to the fourth. That give you the final answer. Okay, just the algebra part, you got to be careful, but otherwise, it's not a difficult case. So something new about it, this is just a product that you have. So we differentiate the x cubed, it's going to be 3x squared. To differentiate this part is a product of two functions, derivative of the first times second, second first. Derivative of the first one, derivative of x squared, just simply 2x. Plus derivative of the second times first, derivative of y squared is what? 2y, but y prime. Anytime you differentiate the y, power rule and the y prime, times the first one, x squared. It's just y to the fifth, 5y to the fourth, y prime, derivative of 7x7. Put the y primes together. We have to subtract this one. So you have two y primes, factor out the y prime. Then you divide by the coefficient of the y prime. So that gives you the final answer. Any question? So that is the role of you see, this equation is very difficult to solve for y to start with, but we don't care.
Sorry, when
Yes.
you solved for y prime, where'd you get the 2x squared from?
2x squared y, you see, this is a coefficient that we have. You see, this is 2y prime x squared. I switch it. You see, I write it down as what? 2x squared y prime. Okay, minus 5y to the fourth y prime. So you pull out the y prime, you drop the y prime. If you drop the y prime, the first one is going to be 2x squared y. Okay, and the second one would be negative 5y to the fourth. Okay, now we divide by the coefficient of y prime. This is your coefficient of the y prime. Any question? So as you can see, the function is very complicated, but we have the y prime. And in calculus, we need the y prime. We don't care about anything else. So we have the y prime, we can find the rate of change, we can find the equation of a tangent line, all sorts of problems that you can take care of by this type of ideas. Any question? Now let's check the kind of application type. So remember, anytime we talk about derivative of the function, derivative of the function would give you what? Would give you, we can find the equation of a tangent line. So we are going to have a kind of tangent line equation, but in this case, using the implicit differentiation, okay? So we give you one of them in this format that you're going to have. It's not going to be a difficult one, okay? So let's get that one too. And then we give you more examples, but I do all the problems from your book so that you'll be fine with this one. So let's check one with the equation of the tangent line. Okay, just using the implicit differentiation. I used to have a nice one, so I'm going to give you that one. When we teach calculus 1, 2, 3, this section is going to be very much involved. But in your case, this is going to be the most that we can do. Okay, just have one. Okay, I'll give you one myself to be able to do it. Okay, so there you are. We want to find the equation of a tangent line. Okay, example. Again, tangent line problem. Tangent lines. Okay, tangent lines, and this is going to be the case for the tangent line. This is a kind of very similar to the one It's a good practice. Okay, we give you one question of the tangent line with the implicit differentiation. There you are. Would like you to find the equation. Okay, find the equation of the tangent line. Okay, tangent line to the graph. Okay, to the graph of the function. Okay, given by this equation. Given by the equation. Equation is going to be explicitly defined. Look at this one. X cubed minus y cubed equal to 6xy. At what? At the point with the coordinate of 3 and 3. You see, this is going to be the case. Remember, we did the equation of tangent line previously, but the equation was straightforward. They give you now find the equation at x equal to 1, x. But for these problems, they give you x and the y coordinates because sometimes it would be difficult for you if you substitute x to get the y. Okay, so it's a tangent line problem. So what we need a point. It's already given to us. We need this slope. That's the interesting part. What's the slope? It's derivative. How are we going to find derivative? You have to find it using the implicit differentiation formula. Okay, so this is how you handle this problem solution. So you talk to yourself that I need a point. The point is given to you. So the point is 3, 3. That's the point. But you need the slope. You need the slope. M slope is what? The derivative. Since the function is y, the derivative would be y prime. Where? At this point. So the way we write it down to remind you that I want to find the y prime is the notation that you may see in your book. At the point 3, 3. You don't have to write this one, but I just want you to see it. Okay? So this means you have to find the y prime. You find the y prime, but at this point is what? When x is equal to 3 and y equal to 3. So you find the y prime, you replace the x by 3 and y by 3, that number would be m. You come back and you give us the slope, okay, of the tangent line. Okay, any question? So let's differentiate it. So we want to differentiate this one. Okay, you have the yx cubed, y cubed, 6xy. Anyone to try this one? Derivative of this equation. You want to try? You have to differentiate both sides, okay? So the first one is easy. What's the derivative of x cubed? 3x squared with that. Minus, no. Derivative of y cubed.
Y squared y prime,
Something is missing. No.
3 in the front.
3 in the front. You see, 3 y squared y prime. You see, you apply the power rule, but you multiply by y prime. So the derivative of x cubed is 3x squared. It's done. But the derivative of y cubed, the power rule first, 3y squared times y prime. Now the tricky one is this side. Is the product of two functions. You see the product of two functions, so I call it fs. So we have to apply the product rule, derivative of the first times second, second first. The first function is 6x. Derivative of the 6x would be just 6. So derivative of the first 6 times the second y plus derivative of the second times first. Derivative of second one. The second one is y. What's the derivative of y? Any suggestion? Derivative of y? Yes, it's 1, but you have to multiply by y prime, remember? So derivative of y would be y prime. You see, because if you think about it as x, the derivative would be 1. But remember, anytime you differentiate respect to the y, you times it by y prime. Or basic derivative of y prime. Okay, that's the derivative of the second times first, 6x. That's it. Okay, so I reordered it. It's going to be 3x squared minus 3y squared y prime. And this is a 6y, I write down in alphabetic order, 6xy prime. Okay, remember we solve for y prime. But the trick is you don't have to solve for y prime right away. Look at this one, what you want? You want the slope. The slope is a y prime at the point 3 and 3. So my suggestion is that don't solve for y prime now. You put the point P, you see x is equal to 3, y is equal to 3 because you have the point 3, 3. Then solve for y prime. Because you have two choices. You can find the y prime first, then substitute, or you better substitute first, find the y prime. That's much, much easier for this type of functions, okay? So substitute for the x and the y, it's going to be 3 times 3 squared minus 3 times y is 3. 3 squared times y prime equal to 6y, 6 times 3 plus 6x, 6 times 3 y prime. Okay, because you want to find the slope. So you substitute for x and the y first, then you solve for y prime. 3 squared would be 9. 9 times 3 would be 27. 3 squared would be 9. 9 times 3 would be 27, but it's a 27y prime. Equal to 6 times 3, 18. 6 times 3, 18. You see? Now solve for y prime, put the y primes together. You have 27y prime here. You subtract minus 18y prime equal to, you get the 18 minus 27. Negative 27 and negative 18, okay? So you just combine the like terms. Over here, I didn't miss any sign. It's a 27, yes. So this would be what? This would be minus, okay, minus 50, that's going to be 15 to 46. Okay, sorry, this is going to be 45. 8 and 7 would be 15, and you get a 45 y prime equal to, that's 18 minus 27, it's going to be a negative 9. So y prime would be equal to the negative 9 over negative 45. You simplified by negative 9, the top and the bottom, so that gives you a fifth. So y prime would be equal to a fifth. And this is what? The slope. You see, that's much, much easier than, okay, than solving for y prime, because you may probably made a mistake when you do the algebra. But since it's the slope problem, just substitute the numbers first, because x and the y would be given to you. So you have the x equal to 3, y equal to the 3. You substitute this number first, then solve for y prime for this problem. Okay, any question? So we have the slope and the point. We write the equation of a tangent line. So what we have the p, which is going to be equal to the 3, 3. So this is going to be x1 and the y1. And we have the m, which is a fifth. And we have the formula y minus y1 equal to the m times x minus x1. Okay, now we substitute, it's going to be y minus 3 equal to a fifth times x minus 3. Okay, you have to simplify, distribute this one. So that give you a fifth times x minus 3/5. Then you have to add the 3, so y would be 1/5 of x minus 3/5. Okay, plus 3. And you just find the common denominator, simplify it. 3 times 5 would be 15. 3, all that give you 12. So y equal to the 1/5 of x. And this would be plus 12/5. So that give you the equation of the tangent line for the given, okay, for the given function. Okay. So, the one that I give you, it's a little bit more involved, but it's not bad. So we have a couple of similar one. The one in your book, they are much easier. Okay, so let's check a couple of them because we give you one of these problems. We want to make sure you know it. Any question, the idea? So there is only one formula really that you apply, and that's when you differentiate respect to the y. Y is a function that you don't have it. So we use the expression y prime for it, or we use the chain rule to get these numbers. Okay. Any question? Let's try a couple of them from your book. This is the one that I give you is very similar to one that you have in your book. You see, and there you are. In your book, you have the x cubed plus y cubed equal to the 6xy, and the point is different. This. So I just change it. It's a very popular problem. That's from my the notes for the calculus 1, 2, 3 that I teach. Okay, so let's get the couple of the one from your book, so then you are happy about it, and then be done with this section. Okay, so I give you one more, and this is going to be from your book. So let's try this number 18. Okay, so this is from section 2.7, number 18. Number 18, you want to find the equation of a tangent line again. Okay, at this point, find the equation, okay, of the tangent line. Tangent line, okay, of the graph of the equation. See, number 18, the equation. I just pick 18 because there are a couple of product. This is the one that we usually worry about. It's x squared y plus y cubed x equal to the -6. At what point? The point is 2 and -1. Let's try this one. Just is a little bit more involved to differentiate it, but it's not bad. So we learn how we take care of those problems. We have two products to take care of. Okay, are you ready? Again, you need a point. The point is already given to you. So you have the point P, which is going to be 2, -1. So that's a point. You need the slope M. So the derivative is y prime. And you have to find the y prime then at the point 2, -1. That will help you if you use this notation. So this remind you that you have to put x equal to 2, y equal to the -1, then find the y prime. Okay. So now let's differentiate. You got to be careful because we have two products. You see, both of them you have to apply the product rule. This is the product rule. and this is the product rule. Be careful. Here you are. Derivative of the first times second. The first is x squared. Derivative of x squared 2x times y. Okay, that's the derivative of the first times second plus derivative of a second times first. Derivative of y is y prime. Derivative of y is y prime. So it's going to be y prime times x squared. That's the first one. Any question? Here of the first one is ordinary differentiation, 2x times second y. Derivative of a second, derivative of y is y prime. Now we go to the second one. Derivative of y cubed, power rule first, 3y squared, but times y prime. Derivative of y cubed, 3y squared times y prime. That's the derivative of the first times second, x. Okay, that's the derivative of the first plus second first. Derivative of x is 1. Okay, derivative of x is 1 times y cubed, 1 times y cubed. But on the other side, derivative of negative 6 is 0. That's the derivative. Any question? So apply the product rule, derivative of x squared 2x times y, plus derivative of a second times first. The second is y. Derivative of y is y prime, so x, y prime x squared. I have a product again here, derivative of the first times second, second first. Derivative of the first one, 3y squared y prime times x. Okay, this is going to be derivative of the first times second plus second first. Derivative of x is 1 times y cubed. Derivative of 6, 0. Remember both sides of the equation. There you are. So what you do is you have the point. You put the x equal to 2. Y equal to the negative 1. And then you solve for y prime. Okay, substitute. 2x. Use parentheses for all of them for substitution. 2 times 2, negative 1. That's the first one. Y prime is the missing one. X is 2 squared. Plus 3y squared, 3 times negative 1 squared. Y prime times it by x. Use parentheses times it by 2. Plus, you can drop this one, is the y cubed, and the y is negative 1. Negative 1 cubed equal to the 0. Any question? Nice to simplify. 2 times 2, 4. 4 times negative 1, negative 4. 2 squared is 4. 4y prime. Over here, negative 1 squared is positive 1. Positive 3 times 2, 6. 6y prime. And negative 1 to the third is just a negative 1. That's it. Okay, just the algebra, usual algebra operations that we're going to do. Okay, that's 1. Derivative of negative 6 is 0. That's how I get to 0. Derivative of a constant is 0. Okay, and now combine the like terms. We get the 4y prime and the 6y prime is 10y prime. Negative 4 minus 1 would be negative 5, equal to the 0. So that gives you 10y prime equal to 5. So y prime is 5, 10. You simplified, y prime would be half. So m is half. That would be the slope of a tangent line. Okay, any question? So they usually have one product, in this problem was 2, that's why I picked this one. So I have the m and I have the point. And we know the formula, y minus y1, m times x minus x1. Substitute, simplify. Y minus y1, and y1 is a negative 1. So it's going to be negative 1, m a half, times x minus x1, which is 2. Okay. So double negative would be positive. Distribute this one, it's going to be 1/2 x minus 2/2. You see 1/2 times 2. We simplify it, so that gives y plus 1 equal to the half of x minus 1. Subtract the 1. Y equal to the 1/2 x minus 1 minus 1. So y would be 1/2 x minus 2. Equation of the tangent line. Okay, so that's a kind of two problems on the implicit differentiation. And you have there is a something. It's a mathematical modeling later on in this course that you have to use a kind of implicit differentiation. You may call it chain rule, okay, because that's a chain rule really. So some people ignore it. They say they don't need to cover this section. It's not the case really. That's a quite interesting concept, and that's why we have to cover it. Okay, so that is implicit differentiation. And that was section, I think that's 2.7. There is one more. I just check. I think we have the quiz next week. So we have to practice for that quiz too. So I probably check the date to get that practice quiz. Just there is one more section. There is a kind of application problems. We call it the related rates problems. It's a kind of application of this idea. And that's also very, very interesting concept. So we try to see if we cover it before the quiz or after the quiz. Okay, we are not going to rush this one, because when we're done with that section 2.8, then the rest is going to be algebra. We are going to be done with these formulas, and then we are ready to take the problem of calculus really. That's how we're going to find the maximum and the minimum. So that would be more algebra, but we have to go through this, to finish it. That's it. So we are up to the 2.7. So I check to see if the practice quiz, the take-home one, and your test, we try to do something by the end of this week. So study this one carefully and look at the problem in your book. If you have any difficulty doing it in, we can talk about it. It's a nice application of the chain rule. That's it. Any question? So take care and see you on Thursday. Bye-bye.